Good afternoon, everybody, or good morning or good evening, depending, of course, in what time zone you are today. Today, I'm going to guide you through the different Azure IoT services that there are available. As already mentioned on the chat, please do not hesitate to post any questions. I will keep an eye on them, and I will handle them during this talk or just before the wrap up at the end. With no further ado, we have a big agenda today. So let's, I suggest that we start because I don't want to run late so that we compromise other sessions today. So let's go. My name is Glenn. I'm an Azure MVP. I'm one of the co-founders of Sure Belgium. Next to that, I'm also part of the Belgium Azure user group, and I'm also a Microsoft certified trainer. As already mentioned, if you have any questions during the session, do not hesitate to post them now, or you can reach me through my Twitter or drop me an email on these email addresses. This session will be recorded or is being recorded. I will share this session afterwards, so you can rewatch them. About Azure, Azure is doing Azure since 2011. We have 3 Azure MVPs, and we have around 50 Azure experts working with Azure day in and day out. We also are a 6-time Microsoft Gold partner. We have, as already said, Microsoft MVP certified trainers, and last year we were Partner of the Year finalist for application innovation. So straight to the subjects. So when it comes to IoT, one of the first choices you have to make is between implementing a platform as a service, so building your own platform, or using a software as a service. The biggest advantage of using platform as a service also comes up with the biggest challenge. The fact that you are in full control of the feature set and scalability and other things brings you a lot of that responsibility. While with software as a service, you gave away that control. It allows you to start quicker, but then again, you have to live with the limitations of the product. So the most important thing is when you are starting an IoT project, or you are thinking of using IoT inside your business or inside your company, make sure that you integrate that IoT strategically. So make sure that your organization is mature enough to go with the new trends, with the new services, and really implement that IoT solution throughout the entire chain of your company. I've seen a lot of companies and a lot of projects that start with a simple proof of concept, and then people after that proof of concept still have to build their business case to convince higher management, to convince C-level that IoT is necessary. While if that decision to implement IoT strategically inside the company is taken from the higher level, higher management, and is carried in the entire organization, then you have more success rate on implementing those IoT projects across your company. So let's start off with a quick helicopter view on the Microsoft IoT product portfolio. And there's a lot of categories over there. So first of all, there's the Azure IoT solutions. And those are your software as a service solutions. So you can, with a couple of clicks, you can get started with IoT. You can start building some of your use cases and so on. A great example there is IoT Central, which is the software as a service offering for IoT of Microsoft. Also, there's a whole range of IoT accelerators, and you can see those as a sort of reference architecture, reference setup that is being built for you by Microsoft. The next major category is the Azure IoT services. And those are the platform as a services that you know. Some of the key components there are, of course, Azure IoT Hub, time series insights, and the device provisioning service. I will come back on a couple of these later during this talk. And of course, the more new kid on the block is the full edge support with Azure IoT Edge, the device SDK, and plenty of the Azure services finding their way to the edge. So you will see that Edge gained a lot of popularity over the last year and is still one of the main focus areas of Microsoft, as it is really key when you do an IoT solutions to have that edge support over there. And of course, all of these services are supported by a thing called Azure Security Center for IoT. And that basically allows you to give some best practices and some guidance on your security level for your IoT solutions. For example, it will give you messages when your devices have been compromised, or if there's something else with your device. It will even go and validate your IoT devices on the edge if the security over there is still going strong. Then the next set of services is more focused on the device side. With Azure Sphere, you have your microcontroller units. Windows IoT is your operating system and your edge devices that have been validated by Microsoft to run or to have been certified to easily and to seamlessly connect with the Azure platform. The goal of this session is today will not focus on these areas. So we will focus more on the SaaS and the platform as a service offerings of the platform. What I do want to mention is that there is a pretty good, decent, pretty nice white paper out there that will tackle the 7 properties of highly secure devices. So this is a white paper that takes you through all of these 7 properties that has been identified that your devices must comply with to be as highly secured as possible. So think about the identity of your device, trust-based computing, error reporting, renewable security, certifications, and so on. So the link towards this slide is aka.ms/7 properties, and there you will find this white paper. So do not hesitate to go and take a look. It's a very interesting white paper that will guide you through these properties. Azure IoT solutions. So if you remember a couple of slides ago, there are two major choices you have to make when there is one major choice you have to make when doing IoT. First of all, will you go for software as a service or will you go for a platform as a service? Azure IoT solutions, as already mentioned, is in the range of those software as a service implementations. So when you think about or you want to implement a software as a service, there's a couple of key components or key things you need to be aware of. So how extensible is that software as a service? For example, are you allowed to access your own data? Are there APIs to interact with? Can you build extensibility points onto that platform? Can you hook in your own logic? Because you know, when you start using a software as a service, I think you will quickly run into things where you say, I wanted to have this feature or that feature. Can I build it myself? Can you? Perfect. Then you can use one of the extensibility points. Think about the offering. So how does the offering of the software as a service platform is compliant with the things you need in your IoT solution? What is the cover rate of your of the software as a service you're implementing on the business requirements you have? For example, if the offerings only cover 40% of that, then I think you will need to make another decision. Another important aspect, of course, is the roadmap. Can you influence that roadmap? How fast is the project moving? What's the release cadence, and so on and so on. One of the Azure IoT solutions, software as a service of Microsoft, is the solution accelerators. Three important things over there is the remote monitoring, predictive maintenance, and the connected factory. As already said, these are sort of reference implementations that are completely open source for you to use. You can deploy them in your own subscription. You can modify them through your needs, or you can even, if you want, you can cherry pick some of the features that are in there and use them in your own solutions. Later on that, I will go into details on that just in a couple of slides. So if you take a look at how these IoT solution accelerators work, is they're basically all built around the same idea. So there's device simulators in there. There's IoT Hub behind the scenes that takes in the data, and there's a whole set of microservices that offer that business logic that you need. And of course, the integration is done with the backend system through logic apps and other processes. What is interesting is that when taking the remote monitoring solution, it has device connectivity, data processing and analytics, and a presentation layer. But the interesting part here is this one. A lot of IoT solution, whether it's you build it yourself with platform as a service or software as a service, require some kind of rule engine. The remote monitoring solution of Azure, or that reference implementation, is using or has a rule engine behind the scenes. As it's open source, you can perfectly use them inside your own solution. So what I did as a matter of a demo, I extracted that rule engine from the remote monitoring solution and deploy that into my Azure subscription, and basically running that that rule engine completely decoupled from the remote monitoring solution, and I'm just using that in my own subscription. So let me just quickly open this this window before we move on. So what I did, I've extracted the rule engine. What I will do is with a device simulator, I will send data towards IoT Hub. The rule engine of the remote monitoring solution is running inside Stream Analytics. It reads the rules from blob storage. When there's a rule triggered, an event will be dropped on service bus. And if everything goes well, we should see a message popping up in Slack where that alerts have been triggered. So first of all, let me show you the end-to-end demo working. So first of all, let me just quickly go to my desktop. All right, this is perfect. So I hope this is readable for you. Let me zoom in a bit. So if you go to the GitHub Azure remote monitoring services.net, you will see there that this is the complete remote monitoring solution that is deployed over there. If you drill a bit deeper, you will see that there's a thing called the Azure Stream Analytics Manager, and this is basically the rules engine that is available for you to use. So what I did is I took that rule engine and deployed it into my own subscription. So let me first show you how this is actually working. So I'm starting up a simulator. That simulator will simulate temperature and pressure. If all goes well, this should start soon. Yeah, so it will simulate temperature and humidity, and inside the rule engine I have defined, there is a certain threshold value configured. So, and if all goes well, we should see some of these alerts being received inside this Slack channel. So as you see, the demo is running, and in the meanwhile, there are alerts popping into my Slack channel. So this is this rule engine is completely standalone, running from the remote monitoring solution. So let's take maybe a closer look on how the things have been set up. Let me move to Azure. And the main component of this rule engine is, of course, the streaming analytics job that is available with the solution. As you can see, it has the input of IoT Hub and blob storage. I don't know why there's some hiccup in the visualization. So it has the input, the rules from blob storage. It takes the IoT Hub data and it stores the alerts both in blob storage and in the service bus queue. Then the logic app is listening on the queue and posting the messages onto Slack. So let me go and take a quick look on how you can define such a rule. So these rules, the rule engine from the remote monitoring is taking in rules in these kinds of formats. So you have to give it an ID, give it a name, a description, and then you have to specify an array of fields that you will monitor. And of course, you have to put in a rule that will be fired upon your data. So important to mention is this is just taken from GitHub. Of course, there's things you can do to improve this, to make this more a production grade solution. For example, you could store your rules inside the database. You could write an API on top of that, but this is just to show how quickly you can extract certain components from these solutions. So let me just quickly show you how the Logic app looks like. It's really nothing special. What it does is it takes a message from the queue and then parses the JSON and posts it on Slack. So that's a fairly simple solution. So let's go back to the slides. All right. So the next major component or major offering is IoT Central. IoT Central is the software as a service offering of Microsoft. It allows you to connect your devices, to process them, to transform them, and so on and so on. It's built on top of Azure infrastructure. It has role-based access control. It allows you to have reporting, define rules, and so on and so on. Let me maybe before we go deeper, I didn't prepare this one, but let's see if we can quickly go to IoT Central. So this is what IoT Central look like. Let me see if there's an. Let me just quickly sign in. So. And here in this window, you can define a new application as you go. And to just demonstrate you how quickly it is to get started with IoT Central, let me just start from scratch here. So I will choose new application. And when you choose a new application, one of the new features of IoT Central is that you can choose from a range of pre-built templates. For example, you can smart meter monitoring. So let's maybe create that one. For example, let's use the free plan or just standards so that I can use my subscription for that. Let me choose this one. So let me provision this in Europe. And as you can see, when I click create, the application will be provisioned, and that application will be provisioned in a couple of seconds. As you can see, it's already there, and it's a template. Of course, this will now start filling with data. But as you can see, it allows you to work with devices, to see certain device properties, and one of the most important entry points is the device templates. And the device templates allow you to define how a template looks like, what the interface looks like, what are the properties, what is the device dashboard, and so on and so on. It also allows you to create certain rules on certain templates. For example, if the power reading is too high, you can do certain actions and so on and so on. So as already mentioned, it allows you to get started quickly, but you have to live with some of the limitations, or you have to live with the fact that not everything is supported over there. So back to the slides. Excuse me. Yes. So the next part is the Azure IoT services. So Azure IoT services is your platform as a service offerings, or your services that will allow you to build your own solutions and to have full control over it. Hello, I think there was an issue with the sound. I hope I'm back now. Thank you for the people on the chat for mentioning it. I hope, let me just let me just restart this where I talk about the IoT Hub scenarios. Thank you for the people on the chat for mentioning it. If someone would can answer, post a question if the sound is back now. Okay, awesome. Thank you. So when taking a look at some of the IoT Hub scenarios, it's important to mention that IoT Hub plays a key role into this. And it's important to mention this is not only for IoT, but it will be a more general scenarios when you start building those cloud IoT scenarios. So first of all, you have devices that can perfectly connect to IoT Hub itself. They are able to talk AMQP, MQTT, or HTTPS. So these devices will connect directly towards the cloud. When you have devices that are unable to talk to the internet or unable to talk one of these three protocols, you can choose to install something what is called a field gateway. A field gateway is deployed very close to the devices, and the devices connect to that gateway. That field gateway is then responsible for doing protocol transformation and then connecting towards IoT Hub. Another scenario is where you have your device that is able to talk to the internet, but it's not able to talk any of the protocols that is supported by IoT Hub. Then you can choose to implement a cloud gateway where you host a gateway in the cloud. The devices connect towards that gateway. You do the protocol translation in the cloud, and you connect it to IoT Hub. And then you have a hybrid scenario where your devices are connected to the field gateway, and your field gateway is connected to a custom cloud gateway. And then there's some protocols that are being exchanged between those two gateways. We often see this setup in more complex scenarios, and more of that. So once your data is then inside your IoT Hub, you can start building those management apps where you control your devices, you monitoring, and so on. And then once you have that up and running, you can start thinking about building your application and using lots of the IoT services. So IoT Hub has a couple of key features for building enterprise IoT solution. It has message processing, message routing, device management, jobs and queries, message enrichments, and so on and so on. So let me quickly briefly run through all of those things and end up with a demo that I've prepared. First of all, there's the message processing. Very simple. Devices send messages towards IoT Hub, and then you can process those events with an event processing. The other way around, you can send messages from the cloud towards the device, and those will be handled and managed by the device. For example, you can send messages, or you can send certain commands to do a restart of the device, and so on. Next to that is message routing. If you have an IoT Hub, you can define custom endpoints. Custom endpoints is next to the built-in endpoint of IoT Hub, endpoints you define that you want to route your messages to. If your messages arrive in IoT Hub, they go through these queries, and based on certain of these queries, you can either route them to the internal endpoint or route them through one of your custom endpoints you defined. You can query both on the twins, on the body of the message, and so on. One of the brand new features or new enhancement that has been released, I think 2 or 3 months ago, is message enrichments. So message enrichment allows you to add certain properties to devices as they come into IoT Hub. I've prepared a demo of message enrichment, so stay tuned for that one. It basically helps you to, if you have multiple devices that are the same, but for example, they do not transmit the device ID or something like that, you can use these message enrichments to feed data that's not inside the message. Of course, device management with the device twins, it allows you to manage certain properties and tags that are there for your management of your devices. For example, you can manage the fan speed, the maximum temperature, and so on and so on. This is all done through the properties and the tags that are built into the device twin of IoT Hub. Of course, as already mentioned, you can invoke direct methods onto your devices, for example, to trigger a restart or to say to the message to update some of the runtime. And then jobs and queries is mostly there to set the state across a whole set of devices. It's there for business logic, reporting, and compliance. So one of the key features when you build big scale IoT solutions is the device provisioning service. Device provisioning service is a way to mass provision devices at scale and to build a solution. In this case, you see that there's an IoT hub in the US, in India, in Japan. So device provisioning service will exactly know to what IoT hub your device needs to connect and needs to provision itself. So it has plug and play provisioning. So when your device comes online, it will automatically connect to IoT hub. It will know to what IoT hub it needs to connect, and device provisioning service is responsible for that one. As already said, multiple IoT hub support. It supports rules and logic. So for example, it can provision your devices on lowest latency, but you can also implement your own custom logic in device provisioning service. And of course, it supports for all devices. And if you want, you can have support for additional data between devices and the device provisioning service. Another important service that is used a lot inside IoT solutions is time series insights. It's a serverless offering that is built for IoT. It allows you to ingest your data at scale. It gives you an UI for queries, and it allows you to model your data and structure your data in certain hierarchies. It also backs up your data in Parquet files, so it allows you to really do some long-term analysis on that data and so on. As already mentioned, there's warm build storage for those direct queries, and that cold storage that allows you to do multi-second queries on the backup of the data that is brought to you by time series insight. It's extensible, so there's queries, you can connect it to Power BI, you can even extract the graphics of time series insight and add them to your own website. So let me quickly jump through to show you some demos. So first of all, we have here, I'm using this MX chip simulator. So if you go to azuresamples.github.io, you will, I will put this on the chat maybe. So here you go. So this allows you to, if you're not familiar with the MX chip simulator, you will see that you're allowed to, to simulate some data that is over there. What I will do is I will quickly show you IoT Hub. I've prepared two to the devices over here, and I have them connected with those MX chips. So what I will do is I will start one MX chip simulator, and I will also start the other one. So if we then take a look inside Visual Studio Code, we start monitoring the built-in endpoints. You will see that we start receiving messages from both the MX chip simulator 1 and 2. You see that both of them, so the MX chip 002 and the 001, have the device ID DevKit Playground. For us, that would mean that inside your solution, does anyone else has issues with the sound? Please ping me on the chat. I see someone mentioning an issue. Anyone else? Hello, is there an issue with the sound? I see someone mentioning something. Please mention something on. Okay, it's back. No worries. So you can see here that the device ID is the same. So what I've did was when I go back to IoT Hub, I've added what is called message enrichment. And if I zoom in a bit, so I'm reading the device ID from the device twin and adding that to the message. So I'm also adding hello world. For example, if I would now add so if I would add this to enrich the message, and I would apply this, and if I would go back to my Visual Studio Code, if all goes well, we should start seeing some messages being enriched with that global Azure tag. So as you can see, this is now being added to the message. So, and this is one of the key features this is one of the new features that has been added to IoT Hub recently. That is really helpful for when you have demos or when you have devices that do not transmit all the metadata you want. You can start adding them in this way. Another thing I wanted to show you is time series insights. So as this is a very interesting service, as you can see here, I have been ingesting data, the temperature of Brussels and Helsinki over the last couple of months. As you can see now here, this is the last, I can query the last 7 days. So you can see here that the data or the queries are rather instantly. If I would query for the last 90 days, that would mean he would need to go and query the data from both cold and hot storage, and you will see that the data will come in a bit slower. It was still quite fast, but yeah, it was not as fast as the first query. Time series insight also allows you to zoom in on certain time frames. So zoom in and also explore the events that were happening during that time frame. So it really allows you to have that that detailed view on your data over your time series data. As already mentioned, you can extract these visuals and use them in your own website. There's a whole API layer for that. You can extract the data as you want. If you do not want to use this visualization, you can perfectly do that. So it offers quite some capabilities. You would, if you want to, there's a big, a good session available. I will post that later, maybe online. I can't remember where you can go into details of this entire service. If you want, you could spend an entire session on it. So even if you want, you can download all the data as CSV and do your thing with it. So let's continue. I see that we have around 10 minutes left, so that's we're a bit sharp on the timing. An important thing I want to mention is that there is a very good reference guide on how to build an IoT solution. It's available on AKAMS/IoT reference architecture, and it's really a foundational guide on how to build your IoT solution. So it really helps you from the ground up. And it also gives you tips and tricks of solutions or patterns that have worked with partners, and that partners are using, currently in production. Edge and device support. I've been involved in quite some IoT projects, and whether it's implementing a solution for a remote mine or talking about IoT solutions on vessels or anything else, having that cloud capabilities on the edge or near your devices is really key in a lot of IoT scenarios. To be honest, I haven't come across a lot of IoT projects where there is no need for a small edge capability. So having that capabilities there is quite key in IoT solutions. So what is now an edge pattern or an edge device? If we take a look at a simple IoT pattern, it's having your things connected to the cloud and creating insights and actions on top of that. You've probably already seen this slide or a similar slide. So this is like your basic IoT pattern. When we introduce Edge, we bring part of those insights and actions back to the device itself, and you create a close feedback loop onto the device. A good example I always try to give is self-driving cars. You want the decision to make an emergency brake. You want that done as close as possible onto the device, and you do not want to wait a couple of 100 milliseconds until the result comes back from your cloud platform. And because those couple of 100 milliseconds maybe can make a difference between life and death if an emergency brake is involved. So Azure IoT Edge is the key service here to support those things, and it exists of a couple of different components. First of all, there's the IoT Edge runtime, where you have your fundamental services running. It provides you the security and the module management. It is managed from the cloud, from IoT Hub, and you can add modules on top of that. Modules are basically simple Docker containers, and they add capabilities to the runtime. You can see it as a sort of a processing pipeline. In this example here, you have your telemetry that can be, for example, Bluetooth connected through a protocol ingestion module here. Protocol ingestion module here that will translate that telemetry, for example, from Bluetooth to something else. It will do some data formatting, and then your Edge runtime will be responsible for transmitting that telemetry towards IoT Hub. The configuration and monitoring is completely done from the cloud. Also, your deployment, your updates, and so on. It's all done from the cloud. Of course, there's some local monitoring available that is for your modules. But if you want to push a new version, you need to go through the cloud, and of course, then you need to be connected. A question I often get is, can this run offline? Yes, this can run offline. The offline mode will be depending on the amount of data that you can store. But if you want to deploy new version, manage your containers, you will have to move. You have to have that connectivity up and running. So the road ahead, when we take a look at some of the new services or the road ahead for IoT solutions, is that there's quite some of the new trends emerging when it comes to IoT. So customers or companies really start thinking about IoT as they want to bring it as a more mature solution, and they want to model a physical environment first, and then keep that physical model up to date with the IoT data. And it's just a much more natural approach for IoT solutions. So the next generation of those IoT solutions will model those relationships between people, places, and devices. And this is of course where digital twins come into play. And digital twins is the service in Azure that allows you to create a whole model or a whole connectivity between devices that you usually use for operation. Think about remote monitoring, fault detection, predictive maintenance, and so on. Your devices will be mapped on top of a space, and that space will give you insights into utilization, think about workplace analytics, and so on. And when you create those insights, you can think about augmenting experience for your users. Think about mixed reality, employee productivity, and so on. Digital twins is currently still in preview, and it's a service that will receive a lot of attention the coming months and years, because, as already mentioned, it's a more natural approach of building IoT solutions without focusing too much on the technical devices part. So before I go to the wrap up, let's see if there are any questions on the chat. I see there is one. I will publish it. Does IoT Central provide support for edge devices? Yes, IoT Central, I think it was added a couple of months ago, Q4 of last year. The edge device was supported, and it's mainly done through the use of plug and play. So I don't see any other questions. So let's continue. Let me wrap up, and then let's see if there are other questions on the chat. So to wrap up, platform as a service, software as a service, the choice is up to you. Depending on your business and your business case, it's completely up to you. The biggest advantage of PaaS, of course, comes with the biggest challenge: the fact that you're in full control of the feature set and scalability. And with software as a service, you gave away a bit of the control that you need, but you, of course, can get started quickly. For customers that need full control over their platform and the feature set they are building is crucial for their business, then PaaS is typically the best solution for them. The most important thing is to learn from your mistake, improve your platform continuously, and as already mentioned in the start, do not treat IoT as a simple project, but try to implement it strategically within your company. So with that said, I would like to thank you. As already said, you can reach me on Twitter or drop me an email. I will be sharing this recording soon. And I will definitely mention something on Twitter about this recording. Let me quickly see if there's any more questions. No more questions. With that said, thank you very much for attending. I saw quite some people online. Do not hesitate to share your feedback on this session. Either through mail or through Twitter. Thank you for attending, and I really wish you a further happy Global Azure. I hope you learn a lot the next couple of days. I hope you will learn a lot the next couple of days and try to stay safe in these times. I see there's another questions coming. I will put the session available as soon as the recording is available. I will put the session online So that will definitely come up. Thank you everyone for attending and see you soon. Bye bye.